Session 4.3 Complements, Conditional Probability and Base Theorem. Complement. The complement of an event E is the event that consists of all the outcomes, not in the E. So remember we talked about the complement under session 4.1. We have an event E and not in the event E. For example, if there is 60% chance of win today, then there is 40% chance that it will not win. So we say the events win and not wins, they are the complement. When you add it up, it has to be equal to 100%. And the complement of the event A is the event that A does not occur. So win and does not win, that will be the complement. The notation for the complement of A, you could use the bar in here. This is represent the complement. Or some other statistic book, they will be using the Z on the right hand corner. Okay, so both of the notation represent the complement. Okay, complements formula. We have a probability of event A plus probability of complement of event A equal to 1. Just like this example, if this is a 60% of the win today, and this is going to be 40%, it will not win. So when you add it up, it has to be equal to 100%. Okay, or you could use the decimal. This is going to be 0.6 plus 0.4. That will be equal to 1. And for the complement, we do have two parts. The first part, we say find the probability of not. Okay, I want you guys to highlight this one. When you see the questions, they are looking for the probability of not something. You're gonna remember this formula, the complement formula. Since we are looking for the probability of not, so you could see I could put P of complement of A in here first. Example 1. Calculate the probability of not rolling a 2 in a fair single six-sided dice here. So again, highlight this one. Find the probability of not. So remember the formula. We are looking for the probability of not rolling a 2 equal to 1 minus probability of 2. Think about it. When you roll a fair single six-sided dice here, what is probability to get the 2? We do have the outcome from 1, 2, 3, 4, 5, 6, right? We have a 6 outcome, and we only have a 1, 2. So it's going to be 1 minus 1 over 6. Use your calculator. You should get 0.8333. Example 2. Find the probability of not drawing a 4 of diamonds in 52 paying cards. Again, we are looking for the probability of not. So write down the formula. Not drawing a 4 of a diamonds. So that will be equal to 1 minus probability of 4 of a diamonds. How many 4 of the diamonds in a 52 paying cards? We only have a 1, right? So calculator, you should get this answer. Can you guys try to do it by yourself for the example 3? Write down the formula first, okay? Okay, again, find the probability of not drawing a spray in a 52 paying cards. So write down the formula. And then we have a 13 sprays in 52 paying cards. Calculator. So that'll be 0.75. So this is part 1. When you guys looking for the find the probability of not, you will use this formula. Okay, this is the part 1. Okay, second part, part 2. Find the probability that an event occurs at least once. then we can find the probability of the complement and subtracting from 1. We're going to apply the same formula, but this time I'll be using probability of A equal to 1 minus probability of not A. Okay, a little bit different from part 1 here. Okay, we just exchange these two guys. When you see find the probability at least once, okay, remember these complement formula. And at least once means 1 or more. So think about it. The complement of getting at least one particular event is that you get no occurrence of that event. For example, if I want to say find the probability to get at least one blue marble, okay, at least one blue marble means I want to either get one or more blue marble. So think about it. What is the complement of get at least one blue marble? How could I write it in a sentence? Complement of at least one blue marble. That will be not to get any blue marbles, right? Not to get any blue marbles or get at least one blue marble. This is the complement. Okay, let's try an example. A fair coin is tossed 5 times. What is the probability that it comes up heads at least once? I want you guys to highlight this one, at least once. Remember, at least once means 1 or more. So first, we're gonna let probability of A equal to comes up heads at least once. Think about it. What is the complement of the probability of A? Complement will be you don't get any heads, right? You don't get any heads. So when you flip the coins, you only get head or tails. If I don't want to get any heads, means I want to come up tails all 5 times. Okay, so this is gonna be the complement. You have to know how to write the complement in order to plug into the formula. Okay, write down the formula. Now we're gonna do it step by step. First, when you flip the coin, what is the probability to get the tail? And for the coin, you only get head or tail. So you have a 2 outcome and you only have a 1 tail. So that would be 1/2. And then second time, when you flip the coin again, what is the probability to get the tail? Same thing, right? It's going to be 1/2. And remember we say that if the probability doesn't affect by the previous one, and we call this is the independence event, right? This is independence event. Okay, how about the third time, when you flip the coin, what is the probability to get the tail? That's the same idea. How many times we're going to flip the coins? We're going to flip the coins 5 times, right? So think about it. What is the fourth one? 1/2. Fifth one? 1/2. Okay, so this is means 1 minus 1/2 times 1/2 times 1/2 times 1/2 times 1/2. I could write it, use exponent. Use your calculator. You're gonna get this one, 0.9688. Okay, one more example. When 4 digits between 0 and 9 are randomly selected with replacement for a lottery ticket, what is the probability that at least one of the digits is 7? Okay, probability of A equal to at least one of the digit is 7. So what is the complement? Complement will be none of the digits is a 7. Okay, so use the complement formula. So for the first digit, I want the first digit is not a 7. So first think about it. How many numbers I could pick? I can pick from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many numbers do I have? From 0 to 9, we do have a 10 outcome. Okay, from 0 to 9, we do have a 10 outcome. And I want to pick the first digit is not a 7. Okay, so I cross out the 7 here. Means that I only have a 9 out of 10. And then second digit is not a 7 again. So same idea, it's going to be 9 over 10. The third digit, 9 over 10. The fourth digit is going to be 9 over 10. Okay, they say when we have a 4 digits, so 1, 2, 3, 4, 4 digits. Use your calculator. You're going to get 0.3439. Okay, so this is the first part of the complement, part 1 and part 2. For the part 1, we have to find the probability of not. Second part, when you want to find the probability at least once, okay? General multiplication rule. So we talk about this on the section 4.2, right? We have the formula P, A, and B. This means the first time we have the A, and then we're gonna find out the probability of B. So that will be equal to probability of A times the conditional probability, right? Conditional probability, probability of B given that or under the situation of A. So this is gonna be the general multiplication rule. Remember this notation? This means like N, okay? Okay, now we're gonna divide it by the probability of A for both sides. Okay, just like the equation, we divided probability of A for both sides. And these two, I could cancel out. So what do I left? I will have probability of B given A equal to probability A and B over probability of A. We call this is the conditional probability, okay? Conditional probability. So this means if I want to find the probability of B given that or under the situation A has happened, that will be equal to probability of A and B, okay? Both of the events occurs at the same time over probability of A. Keep in mind that if the A is the given situation, your denominator is always equal to this number. Okay, if this is A, this is A. Or I could rewrite this formula, probability of A given B. So this time I want to find the probability of A under the situation of the B in here. So you could see my denominator that becomes in B in here. On the top, it doesn't matter. A and B and A, that's the same thing. Okay, just keep in mind the order doesn't matter for these two guys. If this is A, under the situation of A, the denominator is going to be A here. Under the situation of B, then the denominator here is going to be probability of B. Let's try the example. We told one fair 6-sided die here, and we let event A will be the even number. B, that will be the number 1, 2, 3, 4. And I want you guys try to find the conditional probability. Find the probability of A under the situation of given B. So first, write down the formula. Okay, double check. The B is the given information. So the denominator here is going to be the B also. And first, think about it. When you roll the die, what is the outcome? What is the possible outcome? It should be 1, 2, 3, 4, 5, 6, right? This is the outcome. Now think about it. Event A, what is your event A? That's an even number, right? What is an even number in this outcome? Even number, that will be 2, 4, and 6. So let me write it in here, 2, 4, and 6. This is my event A. Okay, how about my event B? 1, 2, 3, 4, right? So I have an event B, and I have 1, 2, 3, 4. Okay, this is going to be the event B. So you could see this is not mutually exclusive, okay, because they do have an intersection in here. Now we're going to plug into this formula. This is what we're looking for. We want to find probability A and B. A and B. So look at this picture. I want to find the probability 2 and 4, okay? Because 2 and 4 is inside the intersection. So what is the probability to get 2 and 4? When you roll a 6-sided die here, 2 and 4, you do have a 2 outcome out of 6 outcome. So that will be 2 over 6. And then probability of B, only B here. So I want to find the probability to get the event B, which is 1, 2, 3, 4. When you roll the die once. So 1, 2, 3, 4, you have a 4 outcome out of 6 outcome. So that will be 4 over 6. So simplify the denominator, you should get 0.5 here. Example 7. The number of United States men and the women in millions, 25 years old and older, who have attained various levels of education as of March 2007. Number of men and women with various level of education in millions. So this is chart. So this is the chart showing the United men and women's the education. Okay, we have not a high school graduate, some college or no degree, and then they give you the total numbers in here also. So now a person is selected random. I want to pick one person. What is the probability that the person is a man? Okay, first I want you guys to find out the total. How many people do we have here? Add up these two numbers. You should get 195. Okay, I want you guys trying to do part A and the part B by yourself. Okay, this is just the basic probability, part A and part B. Show me all your work, what you're looking for, and your final answer, 1 to the 4 significant digits. Okay, A here. What is the probability that the person is a man? So write it down what you're looking for. Probability of man. Basic probability. Favorable outcome over the total outcome. How many person is a man? So we have a 94, right? Out of the total outcome, which is going to be 195. You should get 0.4821. Okay, B. What is probability that the person is a man with the bachelor's degree? So write it down what you're looking for. The man with the bachelor's degree. So man with the bachelor's degree, which is going to be 17.5. Okay, favorable outcome over the total outcome. You should get 0.09874. Hey, pay attention. This is a 4 significant digits. So you don't count the 0. Okay, don't count the 0. 1, 2, 3, 4. Okay, C. What is probability that the person has a bachelor degree given that he is a man? Okay, highlight the keywords here, given that. So you know when you see the given that, we are working on the conditional probability. This means I want to find the probability that he has the bachelor degree under the situation that he is a man. Okay, why did like this way? This line here means like the given that. So we use the formula. On the top, we're looking for the probability of the bachelor's degree and man. Okay, bachelor's degree and man. So you know that will be 17.5. And then over probability of man. The man, we have a 94 in here. So you could plug it in. Okay, last example for the conditional probability. Try to do it by yourself. Make sure when you guys working on the probability, show me what you guys looking for, plug in the word and your final answer. Okay? Okay, the table below displays the results from experiments with polygraph instruments. Find the positive predictive value for the test. That is, find the probability that the subject lie given that the test used a positive result. So again, highlight the keywords given that. So you know we are working on the conditional probability. So we want to find the probability of the subject lie given that there's a lie in here. The test is going to be a positive result. Okay, before that, try to plug in the formula first. Okay, write down the formula. Before you plug in any numbers, write down the formula. So on the top, that will be the probability of lie and positive over the positive, because under the situation is positive, right? So lie and positive, lie and positive. So it's going to be 44. Out of the positive, total positive is going to be add up these two numbers. That will be 58. Calculator. So that will be equal to 0.759. Bayes theorem. Look at the definition. We have two types of probability. One is the prior probability. And this is initial probability value, original calculated before any additional information is obtained. Just what we covered in the previous session, like the basic probability, addition rule, or multiplication rule. This is all the prior probability. And the second type is the posterior probability. The posterior probability is the conditional probability that is assigned after relevant evidence or background is taken into account. And this is also called the Bayes theorem. And we can use the tree diagram to present the Bayes theorem, just like here. All these events must be disjoint. And Bayes theorem is one of the conditional probability. For example, we want to find the initial probability, and that is based on the given information of the subsequent event in here. Okay, so one more time. We want to find the initial probability given that using the subsequent information is obtained. So that will be the Bayes theorem. Okay, let's try this example. An economist believes that the economic growth, the probability of the stock goes up is 0.8. However, if the economic slows down, then the probability of the stock goes down is 0.7. Assume there is 70% of chance that economic goes up. So we try to present these questions using the G diagram. Okay, and then first step, we're gonna let the variable in here. We're gonna let G represent the economic growth. S, that will be economic slows. U, that will be the stock goes up. D, that will be the stock goes down. Okay, so now let's try to use the G diagram. So United States, either the economic growth or economic slows. And then for the last sentence here, assume there is 70% of chance that economic goes up. So we could write it down, the given information here, the P of G will be equal to 70%, okay, means like 0.7. And then since we only consider in the United States either economic growth or economic slows, so you could think about it, this is just like the complement. Okay, so we could find out what is a P of S in here. What's the probability that economic slows? We're gonna using the complement formula. Okay, 1 minus 0.7, that will be equal to 0.3. Okay, and then when the economic grow, the stock, it can goes up or the stock goes down. Okay, and then with the first sentence here, when the economic grows, probability of stock goes up is 0.8. Okay, we know that the stock goes up is going to be 0.8, but be careful. This is based on the given information that economic grows. Okay, so this is going to be the conditional probability. Don't write P of U equal to 0.8. Okay, this is a conditional probability. We're gonna write it like this way. This is means probability that the stock goes up given that or under the situation that economic growth. That will be equal to 80%, which is like gonna be 0.8 in here. Okay, one more time. This is the conditional probability based on the economic growth and the stock goes up. And then we assume that either the stock goes up or the stock could be goes down. So these two guys is going to be the complement again. Okay, so we could figure out this guy that will be equal to 1 minus 0.8 here. But be careful, this is also the conditional probability. We're going to write it like this. Probability that the stock goes down under the situation that economic growth. That will be equal to 0.2. Okay, these two added up has to be equal to 1. Okay, if the situation is economic slows, then the stock is also, it can goes up or goes down. Right, goes up or goes down here. And then we have, if the economic slow down, then the probability of the stock goes down is 0.7. Okay, similar to the previous one here. This is conditional probability. We have the probability that the stock goes down is equal to 0.7 under the situation that economic slows. Okay, and then I want you guys try to figure out what is this one. Make sure you write it down as a conditional probability. Okay, you should have probability that the stock goes up given that economic slow. That will be equal to 0.3. Okay, so right now we just use the tree diagram to present all the question or information from here. Now, let's try to answer the questions in here. Find the prior probability that the economics will slow. So they're talking about the probability that from here, okay, P of S. We just talk about it, that will be the complement of the economic growth. So subtract from 1 equal to 0.3. Okay, B. What is probability that economy grows and stock goes up? So we know to find the probability that first economy grows and then the stock is going to be goes up. So we're going to write it like this. Probability that economy grow and then stock goes up. So we'll be using the multiplication rule here. Remember the formula? Should be equal to that. And then we know about the probability of G already, right? That's a 0.7. And then this is the conditional probability. We got it in from here also. So plug it in. You're going to get 0.56. Okay, C. What is probability of stock goes up? So stock goes up, we're looking for P of U in here, right? But think about it, we do have a two situation that the stock goes up. Either economy grow and then the stock goes up, or economic slows and then the stock goes up. Okay, so we do have a two situation. First one, economic grow and stock goes up, or means like the addition, right? Addition rule. So P of S, economic slows and the stock goes up. Okay, and then we'll be using the multiplication rule again. So this guy will be exactly using the formula from the top here. And then this one, probability that the economic slows and stock goes up will be equal to this guy. Okay, now I want you guys to look at the tree diagram and plug in the information to see what you guys gonna get. Okay, check your work. You should get 0.65 here. Okay, last one. At the end of the year, the stocks went up. What is probability that the economy grows? Okay, this is the asking the base theorem in here. We have the given information. Given information is at the end of the year, the stocks went up. The stock went up is talking about here. All right, this is the given information. And then use this given information to find the probability that economic grows. Okay, so that's the base theorem. So try to work it out first. We are looking for probability that economy grows given that stocks went up. Okay, plug into the conditional probability. And again, this one, probability that the economy grow and stock goes up. We'll be using the multiplication rule again. And this one, P of U, that will be equal to this guy. All right, and then we get it from the part B and the part C here already. Okay, so that will be the base theorem. Okay, you could also using the formula here. When you compare the formula, this is the base theorem. Okay, using the formula. Here, this part, that's exactly same thing what we get it from here. Okay, that will be just like the formula. And then the method 3, we do have the iterative base theorem. Okay, this is going to be method 3. And this method, you're going to assume some convenient value for the total of all items involved. Okay, you need to make up a number. Of course, you want to make up an easy number. And then you need to construct a table of rows and columns. Okay, construct a table with the rows and columns and then fill in all the information here. Okay, we're going to try the next example using like the method 3 here. Okay, example 2. Company manufacturing electronic components for home entertainment systems buys electrical connectors from 3 suppliers. It buys 26% of the connectors from supplier A, 31% from supplier B, and 43% from the supplier C. It finds that 1% of the connectors from the supplier A are defective, 2% of the connector from B is going to be defective, and 5% from the supplier C are defective. Okay, so now you know that we have the connectors, and these connectors made by three companies, company A, company B, and company C. And then the connector, it can be defective or not defective. So now I'm gonna create a table with the three different companies, and for each company, the connectors can be defective or not defective. And then now you need to assume a convenient value, okay? In this example, I will assume there are 10,000 connectors made by the company A, B, and C. Okay, so total has to be 10,000. And then using this information to fill in the table here. Okay, 26% of the connectors from the supplier A. Okay, so I will have a 10,000, the total number of the connectors times 26%. So you have 2,600. And then they say 1% of the connectors from the supplier A are defective. So from the supplier A, that will be defective. That's a 1%. So I use 2,600 times 1%, which is equal to 26. Now you need to figure about it. If total connectors made by the company A is 2,600, and then 26 of them are defective. So how many of them is going to be not defective? You could subtract it, right? Right? The total number of the connector made by the company A minus 26 of them are defective. So you're going to get this number. Okay, now I want you guys to use this information. Try to fill out this table. Okay, check your work. And then after that, find out the total number of the connectors are defective. So add it up here, the column 1 here. And then add it up here, find out total number of the connectors are not defective. Okay, double check, add it up, the total has to be equal to 10,000. Or here also, total has to be equal to 10,000. Okay, now we're gonna answer the questions here. If an electrical connector is randomly selected from the general population of all suppliers, find the probability that it was made by company A. Okay, so we are looking for the P of A. So made by the company A will be 2,600. And then out of the total number of the connector, which is 10,000. Okay, so that will be 0.26. And then find the probability that it is found to be defective. Okay, it has to be defective. Now look at the table. How many total number of the connectors are defective? That will be 303, right? So we are looking for P of D. Okay, P of D. So P of D will be equal to 303 out of 10,000 for total. Okay, last one. If a customer buys one of these components and finds that the connector is defective, what is probability that it came from the supplier B? Okay, again, this is the base theorem, conditional probability. We are looking for the probability that it came from supplier B, given that the connector is defective. Okay, connector is defective. So we're gonna write it down here. Probability that's made from the supplier B, given that the connector is defective. And then we're gonna plug into the conditional probability. Okay, so now here we are looking for the probability that made by the supplier B and defective. So made by the supplier B and defective. Okay, defective. So it's gonna be 62. And then what is the total number of the connector is defective? That'll be 303, right? So just plug it in. then you're gonna get this answer. Okay, so now I talk about like the three methods. First one, using the tree diagram. Second one, straightforward using the formula. Number three will be using the iterative based theorem. Okay, just create the table and then make up convenient number. Okay, and try to make an easy number. If you try to find and make a number, and when you multiply like the percentage, you're gonna decimal, you may want to try to make another number. Okay, it will be easier. Okay, example 3. Similar example. I want you guys either using the method 1, method 2, or method 3. Okay, you don't have to know all of the method. You just pick one is easy for you. Okay, try it by yourself, and you could try to work after that. I will show you guys the tree diagram method and also the iterative based theorem method. Okay, first, you should create the tree diagram like this, made by three companies, company A, company B, and company C. And for each company, it can be defective or not defective. And then plug in the information here. Company A makes 80% of the ELTS in here. So P of A equal to 0.8. And then company B makes 15% of that. So P of B equal to 0.15. And then the last one, company C, makes the other 5%. So P of C is going to be 0.05. And then made by the company A have a 4% weight of defect. Okay, this is conditional probability. Probability of the ELT is a defective given that it made by company A. Okay, so you should have this guy. Defective given that made by company A equal to 0.04. And then this is going to be the complement, either defective or not defective. Okay, subtract from 1, you're going to get this guy. Second one, made by the company, the probability that the ELT is defective given that made by the company B. Okay, and then complement again. You should get this one. Okay, company C, check your work here. Okay, so we're just using the tree diagram in here. And then answer the questions. So find the probability that it was made by the company A. We got it from here, P of A is equal to 0.8. Find the probability that it is found to be defective. Okay, found to be defective. So we do have a couple situations. Either it is defective made by company A, or it is defective made by company B, or it is defective and made by company C. Okay, so what did learn like this? Made by company A and defective, or, so additional rule. Made by company B and defective, or made by company C and defective. And then for each of them, plug in the multiplication rule. And then plug in all this number here. Okay, and then see if a randomly select ELT is then test and is found to be defective. Find the probability that it was made by the company A. So this is the base theorem, right? This is a conditional probability. We already know this ELT is defective. Okay, this is using the additional given information here. And then I want to find the initial probability. The probability that it was made by company A. Okay, probability of A, given that the ELT is defective. And this is A and D. You could get it from here, right? Probability A and D. So it should be this guy here. And the probability of defective, these three numbers, I get it from here. you should get 0.703. Okay, this is how you guys using the tree diagram to answer the questions. And then if you try to use an iterative Bayes theorem, okay, that will be the same questions. And I assume the 10,000 ELT also. Okay, so calculate one by one. Check your work. Okay. And then answer the 3 questions. So find the probability that it was made by the company A. Company A is 8,000 out of 10,000. So that's 0.8. Find the probability that it is found to be defective. So the total number of the ELT a defective is going to be 455 and out of 10,000. C. If a randomly select ELT is then tested and is found to be defective, find the probability that it was made by the company A. So write it down, conditional probability. Probability A and D. So made by company A and defective, that will be 320. Probability of defective, so it's going to be out of 455. Okay, you're going to get the same answer when you're using the tree diagram.